Hello, everybody. This is Mr. Kuchenmeister here, and this is the video for Monday, November 17th of 2025. This is the video to going through 4.3 while I am out. So we're going to get started by going through the 4.2 activity that you should have gotten before going through this note. So if you haven't attempted the activity, you should do this first before looking at this video. So please try this on your own, because this is normally what I would have done in class. I would have given this you time to work on, and then we would go through them as a class. So since I'm not here, I can't do that, but we're going to go and get started, and then we're going to jump into section 4.3 and go through that lesson real quick. So let's get started. Okay. So we got this triangle, we got this diagram here on the right where we got multiple triangles here. A small note, I'm not sure if this is on your worksheet, but this point D is actually this point right here. So ignore that, but let's go through it. Okay, classify each triangle by its angle measure. So we're going to start off with triangle ABD. Triangle ABD is this right triangle here. And what we have here, friendly reminder, ways we can classify triangles is by their angles. So when we're doing by angle measure here, I have an angle that's 50 degrees, an angle that's 100 degrees, and we'll talk about how to find that third angle later. But the fact is, I have an angle that's over 90 degrees and less than 180. That's an obtuse angle. So triangle ABD is an obtuse triangle. All right, so let's move on to triangle ADC. So triangle ADC, oops, I want to switch colors. There we go. So triangle ADC is this whole triangle here. So it's kind of hard to see by the diagram here, but you do have a right angle mark for angle ADC. So this angle right here is a right angle, so that makes it life easy here. It is a right triangle. And lastly, if we take a look at triangle BCD, I'm going to erase some stuff here, maybe. So triangle BCD is going to be B to C to D is just this left triangle here. Okay. And here what we're going to have is, all right, we're going to have a 40-degree angle right here. We're going to have an angle that's less than 90, because I know the whole angle is 90 because we just talked about it. And then this angle I can find out is 80, because that's DBC. That is because we have a linear pair here. All right, so the measure of angle DBC is going to be 80. And this is linear pair theorem. So that makes this, we know 40, 80, this angle is less than 90, so this last triangle BCD is an acute triangle. All right, so let's go ahead and move on and talk about labeling triangles by their side length. So side lengths, we have three choices. We have scalene, we have isosceles, and we have equilateral. Scalene is no sides congruent, no congruent sides. Isosceles is at least two congruent sides. And equilateral is all three sides congruent. All right, so I'm looking at triangle HIJ. So that is H to I to J. All right, that is a triangle where all three are marked congruent with one tick mark. So all of those sides are the same. So this is an equilateral. I'm going to go equilateral triangle. All right, moving on. At triangle DHI. So triangle DHJ is this guy. We have a congruent side here, a congruent side here. And this side, we know it's 6.9, but we don't know what these other two are, so we just know that we have at least two congruent sides. This is an isosceles triangle. And lastly, the whole thing here, okay, is triangle GIJ. So we have side GI is made up of GH and I. So, you know, this is something you can do if you consider this side X. That means all these guys are X here. So I makes up this whole side of here is 2X. This side is X. This is 6.9. There's nothing we can really do here, but we just have enough information to say, hey, all of these sides are different. This side is X. This side is two of those. So they're not the same length. And then 6.9 is not marked. We know it's not equal to those. So that being said, this is a scalene triangle. All right. So one of these triangles here falls into two classifications. Which triangle is? Well, you have to look at the definition. So remember, we talked about an isosceles triangle in 4.2 being at least two congruent sides. Remember, the phrase at least means, you know, a number or more. So when I say at least two sides, I really mean two or more. So two triangles that actually fall into the triangle that falls into two classifications is actually triangle HIJ, our equilateral triangle. Triangle HIJ is not only an equilateral triangle, it is also an isosceles triangle. All right, technically every equilateral triangle is an isosceles triangle because all you need for an isosceles triangle is at least two congruent sides. So if you have three congruent sides, that falls into the phrase at least two. So let's make the note of that, all right? Isosceles doesn't mean two congruent sides, it means at least two congruent sides. All right, so moving on. Okay, now we're gonna look at this, all right? Acute, right, obtuse, equilateral, scalene, recur. So based off the markings here, what type of triangle is triangle PQR? Well, here you got two sides marked congruent. So we know here that side RP, so that segment RP is congruent to segment RQ. And we don't have a third tick mark, so this is an isosceles triangle. We can't make a claim about the angle measures because we're told nothing about the angle right now. We will soon learn what we can do with an isosceles triangle, but that's later on in the chapter. Okay, so now I want to solve for x. Well, what I can do, you know, this goes back to basic process of congruency. The two things are congruent, their segment lengths are equal. So now what we can do is we can go 3x minus 0.4 equals x plus 1.4, and we can do some algebra to solve for x here. Subtract x from both sides, get 2x minus 0.4 equals 1.4. I would add 0.4 equals, goes to 2x equals 1.8. Divide both sides by 2, and x is going to equal 0.9. All right, so x equals 0.9. Now we can plug in here, okay? So we want to do side PQ here, which is that bottom side here. All right, so I'm going to get side PQ equals, or segment PQ equals 0.9 plus 0.1, which is 1. And then for the other two, side PR is the 3x. So PR equals 3 times 0.9 plus or minus 0.4. This, which is going to equal 2.7 minus 0.4, which is 2.3. Now, hypothetically, right, since we have congruency marks and we know RP is congruent to RQ, this should also be 2.3. But if you wanted to double check yourself, we can always go back and plug in here. We go RQ equals 0.9 plus 1.4, and that equals definitely 2.3. So life is good there. All right, and lastly, what you had to do is you had to classify these. They use the markings on the diagram to classify the triangles by angle measures and side lengths. Some triangles may have more than two classifications. All right, so it always makes sense to have a classification by side and a classification by obtuse. Looking at this first one, if I look at the sides, all three sides are different lengths. So that is scalene. And then I only know one angle, it's 100, but that is an obtuse angle, so that makes this an obtuse. So we have a scalene or an obtuse scalene triangle. All right. Looking at this next one here, we have 3 congruent sides, so that makes it equilateral. We have 3 equal angles, which makes it equiangular. And then we have, since it is equilateral, it also means it's isosceles, technically. So you got 3 different classifications for this one. Here, we have a right angle, so it's a right triangle. And then we have 2 congruent sides, which is an isosceles triangle. So this is a right isosceles triangle. So hopefully you had those. If you have any questions on those, make sure from there, right? But these are basically the words we can use when we classify triangles. Hopefully that made sense. All right, now we're going to move on to section 4.3, which talks about angle relationships and triangles here. Our goals are to find the measures of interior and exterior angles. And then we can also are going to apply theorems about interior and exterior angles of triangles. So we're going to bring back some proofs here, not a ton, just 1 or 2. And then we're also going to talk about some corollaries, which we'll explain what those are in a bit. But let's go ahead. So this is all about our angles in triangles here. All right, so starting off, star this theorem. This is a super important theorem, this chapter. It's a pretty easy one, but it's going to be one you are going to be using throughout this section. So we call this the triangle sum theorem, and its theorem simply says sum of angle measures of a triangle is 180 degrees. We have a triangle ABC on the right here. We have the measure of A plus the measure of B plus the measure of C equals 180. And notice how it's very general. It doesn't matter what type of triangle it is. All right, it is just stating the fact that, hey, no matter what type of triangle you have, all the angles must add up to 180. Why does that matter? Well, if you know 2 angles, you can find the third. And in some cases, if you know 1 angle, you can find the other 2. So let's do some practice problems here. So we got to do a little bit of a diagram here, all right? So the map of France commonly used in the 1600s was significantly revised as a result of a triangulation land survey. The diagram shows parts of the survey map. Use the diagram to find the indicated angle measures and justify each step. Alrighty, so we're looking up here. Okay, so I can't remember. I'm going to be using this diagram. You guys might have just what's left here, but go from here. All right, so starting off here, all right, we want to find the measure of NKM. So measure of NKM, I'll signify with a red dot on the map here, is going to be this one right here, okay? If I'm looking at it here, I have a triangle NKM at the bottom here with angles 48 degrees and 88 degrees. So what I can do here is I know that these 3 angles have to add up to 180 here. So if I were to write an equation here, I would say the measure of NKM plus this bottom angle that's 88 is KMN. So measure of KMN. Plus this other angle, the measure of MNK, equals 180 by the triangle sum theorem. So that's going to give us, we don't know this, we don't know NKM, but we know the other 2. This one is 88, this guy is 48. All right, do some quick math here. 88 plus 48, I'm being lazy, sorry, 136. So measure of NKM plus 136 equals 180. Subtract 136 on both sides, and we get the measure of NKM is equal to, we got 44. So this guy is 44 degrees. All right, moving on to JKL. So JKL will switch to blue. So here we go. So we got JKL here is going to be this guy right here. All right. Well, what you kind of have here, this is kind of old, right? You have the angle we just found, this angle here, and now the blue angle that we have are all part of this line right here. So we know this angle right here, that's with the 44 and the 104 and this, is going to be equal to 180 because it's a straight line, right? So another way I can do this, I can say, well, it's going to be equal 180 minus 104 minus 44. And that is going to equal 32. All right, this guy is 32. Okay, and you do, this is just definition of straight angle. Okay, this first one here was triangle thumb theorem. All right, lastly, we got to find JKL. So we're going to go here. So we got J, we got K, and we have L. Oh, oops. Oh, wait, this is the same one. Never mind. We don't need to redo that. All right, let's move on. Okay, so here's a kind of a proof of kind of how we did it here. And I'm trying to remember here, I don't want to waste your time if this is not on your note sheet. So let me quickly, real quick here, pull it up. All right, so looking at your note sheet here. All right, it is, looks like. Okay, so what wasn't on your notes was the last slide, so it's okay. All right, so if we're kind of looking at this here, so what we can kind of do is we're going to assume basically what I just did here. We're going to add this. So if I look here, all right, the end goal is to find NKM. So NKM, if I look at the diagram here again, is this top angle here, right? So if we're looking at kind of trying to come up with a proof here, all right, this is a way we can kind of use triangle sum theorem. So first off, looking at it here, okay, so we're given the measure of KMN plus the measure of NNK plus the measure of NKM equals 180. This is triangle sum theorem. And you can abbreviate it here. Okay, and then what we're going to move into, we're going to fill out what we know. All right, this is exactly what I did in the first example here, except without the proof. So KNM is 88 plus MNK is 48. And we don't know the measure of NKM, so we leave that as that. Our reasoning, substitution. All right, you should know what's next here. And what's next is we're going to simplify. We're going to do 88 plus 48, which if you remember, which right here is 136. Now we have 136 plus the measure of NKM. And that is going to equal 180. And lastly, I would subtract 136 from both sides to get measure of NKM equals 44 degrees. And then subtract the proper dual. All right. So now we're going to kind of use the same diagram, and what we're going to do is we are going to try to find, our end goal is to find JLK, right, which is kind of what we just did. Okay, this is kind of why I showed you guys the math first here, just to show you that it's not crazy, but now we're just kind of putting it in terms of a proof here. So starting off here, we again have measure of NKM plus the measure of MKJ plus the measure of JKL equals 180. That's using the fact that, again, I'll show on this diagram that what you have here is a straight angle. So a straight angle is 180. So we kind of combine two things into one step of a proof. We're at the point now where we can kind of do this. We can put multiple steps in here. All right. And now we're going to substitute. We're going to do NKM, which we just found in the last was 30. I've already forgotten. It was 44. We have 44. MKJ by the diagram here is 104. And then JLK, we don't know. Or JKL. Yep, JKL, yep. So substitution. 44 plus 104 is 48. 148. And then simplify. Subtract 148 from both sides to get 32. We get measure of JLK, or JKL, sorry. Equals 32. And that is subtraction property. Okay, so that's that. We now have this. So I'm going to fill in what we know. So we know this is 44. We know this is 32. Now what the proof wants us to do is we want to find JLK. So JLK is this guy right here. We're trying to find this angle. That's our end goal right now. Okay, so now I'm just going to focus purely on this top triangle. All right, it says the measure of JLK plus the measure of JKL plus the measure of KJL equals 180. That is our new theorem. That is triangle thumb theorem. Basically, when you're using a proof with triangles and you use angles, triangle sum theorem is going to be your best friend. So I'm going to not be lazy here and write it out. Triangle sum theorem. Again, we now know too, this is just a formal way of putting it into a proof. All right, so we know, we don't know JLK, so that's what we're trying to find. We just found this in the last step, so that's 32. And by the diagram, this is 70. So that is another substitution. A lot of substitution, a lot of simplify, a lot of subtraction. Because there's really just a lot of algebra here. So measure of JLK, 32 plus 70 is 102. Simplify. And we'll subtract 102 from both sides to get measure of JLK equals 72. I'm sorry, 78. And we're done. I didn't need the last line. Cool. So, find some application with mine, but this is kind of why I did what I did here. Okay. Now that I look at this, we could have just done this by, they were the same thing, but just looking for reading fast here. So if I come back to this one, right, we can just do triangle thumb theorem again, 32 plus 70. I'm not going to bore you because you just did it on your notes here. But again, to show you that proofs are really just a nice way in geometry of writing stuff up. Okay, you can do it either or. Okay, so now we're going to get into, kind of the bulk of the lesson. All right, so first off, we have to talk, you're going to get a new vocab word. I believe this is definitely on your vocab sheet. We're going to talk about what a corollary is, okay? Or some corollary or corollary, please don't yell at me about pronunciation. Basically what it is it's a theorem whose proof follows directly from another proof. So we know we have theorems in this class, right? And typically those are the big boys. But sometimes what happens is a corollary kind of stems off of that. And it uses the theorem it's a part of as to make its own little statement, okay? You'll kind of see what I mean because we're going to kind of use this in action here. But basically, it's a type of theorem whose proof follows directly from another theorem, okay? It uses another theorem that we've already talked about to kind of make sense. So the two we're going to focus on are two corollaries that stem off of from the triangle sum theorem, okay? So these two corollaries that I'm going to show you use the fact that we have this theorem, okay, which is the triangle sum theorem. Okay, I'll try to explain this in the best way I can. All right, so looking here, we have these two. There's no names for it, but the corollaries we have for this section are going to be for the following. first one is the acute angles of a right triangle are complementary. Okay, so this says, hey, if you have a right triangle, which means we have a triangle with a 90-degree angle, then they're saying, well, then the other two angles, this angle and this angle, have to be complementary, or in other words, they have to add up to 90. Well, why is that the case? Well, because the triangle sum theorem says that all angles in a triangle add up to 180. All right, so kind of think about it for a minute, right? If you know all three of these add up to 180, right? We know this is 90. Well, that means the other two have to add up to 90, otherwise the original theorem fails, okay? And then the second one is for equal angular triangles, and that states, well, the measure of each angle in an equal angular triangle is 60 degrees. Why is that the case? Well, all angles in a triangle add up to 180. If I have three angles that are the same size, well, then I'm just going to divide 180 divided by 3, and I'm going to get 60. All right. Ooh, the Cavs just started. See, that's how you know I'm here late, when the Cavs start their game at 7 o'clock. All right. Let's go ahead and finish this. All right. All right. One of the acute angles in a right triangle measures 92.9 degrees. All right. So I guess we'll call this one 22.9. Well, what is the measure of the acute angle, other acute angle? Well, you have two choices. So we could do triangle sum theorem. We'll call this x. All right. So one way we could do this is we could say x plus 22.9 plus 90 equals 180. All right. This is the regular theorem way. So there we combine like terms. We can go x. 90 plus 22.9 is 112.9 equals 180. I'm do 180 minus 112.9 is 67.1. That's subtracting 112.9. But another way you could do it is you can just go with the fact that, wait a minute, okay, I have a right triangle, right? So that means this angle plus this angle better be 90. So another way you can do it is you can use the corollary, which states that x plus 22.9 must equal 90. X 22.9, and you're going to get x equals 67.1. Either way, you get your answer. The other angle is 67.1. All right. All right, some more vocab. Last thing in this section, we're going to talk about interior and exterior angles, okay? So I'm not going to waste too much time. You guys can all read here, okay? But we're going to talk about the interior and exterior angles in a triangle here, okay? So first things first, you guys all know what the interior and exterior means. It means inside and outside. So when we're talking about interior angles of a triangle, we're obviously talking about the angles inside of the triangle that are formed. You have angles 1, 2, and 3. These are all on the inside. And sometimes we'll get triangles that are made up of rays and lines. So you might have angles that get created on the outside. So we have a segment here for angle 1 and 2, a segment for 2 and 3. But the side for angles 1 and 3 is a ray, which contains an outside angle. So we call this an exterior angle, right? And if I really wanted to, I could add on. I've done this before when I've taught this lesson. You know, here I'll extend this side. Now I get create angle 5. Oh, I'll extend this side, and now I have angle 6, right? So 4, 5, and 6 would be exterior angles, all right? But I'm not going to do that to overcomplicate the diagram. I'll go from there, all right? The new word you might have is called a remote interior angle. And what a remote interior angle is an interior angle that is not adjacent to an exterior angle. So look at this diagram here. 1 and 2 are remote interior angles to angle 4 because they are not adjacent to 4. Remember, adjacent means common vertex, common side, and these two are not even close to 4. That's going to be important in this next theorem here, okay? And that theorem that we have is called the exterior angle theorem, also a pretty important theorem that we're going to use in this class. What it states is the measure of an exterior angle of a triangle is equal to the sum of measures of its remote interior angles. So if we look at that diagram, I've simplified that diagram from the last slide is, Okay, we know 1 and 2 are remote interior to 4. What this angle says, this proof says, is this angle here, 4, equals the sum of 1 plus 2. And we can do that for any triangle, right? Again, if I could extend this one, I'll just extend this one. We'll call this angle 5, right? The two remote interior angles to 5 are 1 and 3. So I could say the measure of 5 equals the measure of 1 plus the measure of 3. It works the same thing, but again. All right, some practice problems here. So this is where you can kind of throw it in here. All right. So find the angle, find the measure of angle J. Okay. So this is an example where you can kind of use what we've learned, and we're kind of getting to the point where there are multiple ways to do this. All right. But here's an example of the remote exterior angle. Okay. So what we're going to do is we have this angle, we have angle DHJ equals 6x minus 1, and we have angle DJH equals 5x plus 17. So I'm not told the third angle. More importantly, I don't know what these two angles are, so I really can't do triangle sum theorem to find x. But I have an exterior angle right here that is 126. And since these two angles right here and right here are remote interior, I can use this theorem here. So, and that's what I'm going to do. So this angle on the outside is angle HTF. All right. So I'm going to say by the exterior angle theorem. Oops. By the exterior angle theorem, we have angle HTF equals, or I should say the measure, equals the measure of angle DHJ plus the measure of HJC. Or in other words, if I substitute 126 equals 6x minus 1 plus 5x plus 17. From here, it's algebra. 6x plus 5x is 11x. Negative 1 plus 17 is negative 16 equals 126. We'll add 16 to both sides. All right, we're going to get 142 equals 11x. And then divide both sides by 11. We get x equals 15. So now we can come over here, plug in for angle J, measure of angle J, which is the same thing as saying the measure of HJD. That's going to equal 5 times 13. Lost my train of thought. And go from there. All right, so that'd be 65 plus 17. And we get 5 plus 7, 12. We get the 1, 7 plus 8. We get 82. So measure of angle J equals 82. Okay, moving on here. Last theorem, this is called the third angles theorem. Okay, again, pretty kind of self-explanatory theorem, but I'll explain what it is. So this angle uses two different triangles. And what it states is that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. So look at these two triangles. What this says is, if you have two pairs of angles that are congruent, so in this case we have L is congruent, so angle L is congruent to angle R, and then we have angle M is congruent to angle S, okay? Notice how these have two tick marks. What that's basically saying is, hey, all four of these angles aren't congruent. It's just you have L is congruent to R and M is congruent to S, okay? What this says is, if you have that, well then logically using triangle sum theorem, angle N and angle T better be congruent because it kind of stabs off the triangle sum theorem. So what you can kind of come in right here as well, then these have to be congruent. And yes, you have to use 3 tick marks now. So that's what this says. So how can we use it in a problem? Find the measurement of angle C and angle F. All right. So I have two triangles here. Okay. Once again, this is where I can use third angle theorem. I know that angle A is congruent to angle D. I have angle A is congruent to angle D. I also know that angle B is congruent to angle E because they're both 90. And since two things are the same measure, look there. So angle B and E are congruent. Well, that means by third angles theorem, angle C must be congruent to angle F, which means the measurement of C must equal the measurement of F. So what that means is we're going to have y squared must equal 3y squared minus 72. And now let's solve this. All right. So let's subtract 3y squared. We'll get negative 2y squared equals negative 72. Divide both sides by negative 2. We're going to get y squared. Negative 72 divided by negative 2 is 36. We've got to take the square root of both sides, and we get y is equal to 6. And that is our answer. Well, it's not our answer. Now we have to find measure of C and F, but would you agree you just got to plug it into one of the answers? I would just plug it into measure of C. Measurement of C equals 6 squared, which is 36. So both of these guys are 36. Very good. And you could plug it in for this one if you want, but no need. All right, that's it for me. I'm sorry that was kind of long, but again, I wanted to go through that in-class activity just like I would if we were in class. So hopefully now, so it's about 40 minutes in. So on a regular day, you probably have about another 20, 25 minutes. Use this time wisely to complete the homework 4.3, and I will see you guys next time when we'll pick things back up and do 4.4. All right, guys, see you later.